Can you hear me okay?
Yeah.
Great, fantastic. So I always like to start with a story. I think sometimes it really makes a point. So even prior to the 1980s movement towards open source, the concept of technological information existed many, many years before computers. So take the example of automobiles, for example. Okay. Back in 1911, right? Actually way before 1911, a group of capitalists owned the rights to a two-cycle gasoline engine patent originally filed by George Sheldon. Now this patent allowed them to monopolize the industry and force car manufacturers to adhere to their demands or risk lawsuits. Now this is where Henry Ford comes into the picture. He challenged the Sheldon patent, and the result of that challenge was that the patent became virtually worthless, and as a result, a new association grew out of that called the Motor Vehicle Manufacturers Association. Now this consortium instituted a cross-licensing agreement among all US auto manufacturers. Now each company could develop their own technology and file their patents, but in addition to that, these patents could be then shared openly and without the exchange of money or the risk of lawsuits between the manufacturers. And you can see that this approach accelerated the innovation and the availability of those technologies to mainstream consumers. Now fast forward to 2015, today. Again, we are at a pivotal point in history as we look to open source to accelerate innovation and adoption of the Internet of Things. Now, having just heard the lecture from PeoplePower, a similar comparable competitor would be iControl, is that we think that those things can coexist. And from my research, what we found out is that a lot of those proprietary underneath them are these open source technologies I'm going to cover. So what is open source and why open source? Okay, and then what I'm going to cover for the duration of the next half an hour or so is the research that we conducted at an industrial level around the IoT open standards, platforms, consortiums, and toolkits. I'll briefly cover our methodology and the study results, and then briefly application of how those best-in-class capabilities can be applied to different sectors and business use cases. And finally, what are some of the issues, concerns, and limitations that we need to be mindful of as practitioners within our respective enterprises and startups? Now, when we think about open source, there are many drivers to embracing open source. Consumers want to use a variety of devices. So for example, if I purchase a certain smartwatch, I don't want to be limited to pairing it with a particular smartphone, right? I mean, that's an issue. Similarly, in some of your cases, as vendors of IoT devices, we want to increase the number of ecosystems where their devices can be integrated without major effort. And for application developers, which I'm sure many of you are, you want to be able to support a broad range of devices without a need to develop vendor-specific code, right? So what does open source allow? Well, it allows for scale. So we know that based on some of the projections that this could scale to 50, 70 billion sensors in just the next decade alone. That means that potentially there could be millions of routers, gateways, and data servers. And there's simply no way to achieve this kind of scale without relying on open source frameworks and platforms to scale that infrastructure. Any other approach that you try to look at would just simply be unaffordable. Now, in order to support rapid velocity of innovation, you need several conditions. One is what I just mentioned, low cost, right? Open source allows us for a more natural adoption approach within an enterprise. It's free, it's generally easy to download and install, and it gets you started fairly quickly. It allows you to be able to experiment and explore, and for enterprises to get comfortable with the software on a smaller, non-mission critical project basis before you make any type of financial commitment required. It's royalty free. It means that it's permissionless innovation without the worry about royalties or lawsuits. And in particular, open source allows for innovation by integration, where developers create new systems by combining freely available open source components together. Vibrant developer community. These open source projects tend to innovate faster than proprietary solutions in some cases because there is a contribution from a larger community of developers. And when you think about the accumulation of these communities working together, they're able to accelerate the delivery of key features and that ecosystem that the enterprises need. And the result is that open source is usually able to deliver faster on-target capabilities than some of the proprietary alternatives. Interoperability. Now, the best way for having a new technology achieve rapid adoption is by combining open standards with a robust open source implementation. Now, open source implementations provide an easy adoption path with interoperability and reduces the cost of entering a particular market. And developers can spend less time implementing a standard and focus building on the software that's going to provide that firm with product differentiation that their customers are going to value. No lock-in. A key advantage to open source is this notion of no lock-in. Because when you work with a proprietary solution provider, the switching cost is high, and that's intentional. It's there for a reason to keep you hostage to these proprietary service providers. And that also extends to support. And you want to be able to mitigate the risk of being tied down where potentially that solution that you're depending on is going to be discontinued or no longer supported. And certainly, as many of us have experienced, you purchase these proprietary softwares, and what happens is that you start to add on all these costly customizations, and you're stuck potentially down the road with unsupported systems, or a costly upgrade path that most of us have experienced. What this presentation is going to briefly cover, and please keep in mind, if you're not able to take notes, that's okay, because there's going to be a detailed report that's going to be coming out in the summer that you can subscribe to. So we'll just briefly touch upon it, but it's okay if you don't get all the details. So what we've done is we've done an industry-level study on open source projects. In regards to the scope of the study, we attempted to obtain a cross-section of open source projects, and keep in mind the scope was not to get 100% comprehensive coverage, because when you take into account the different projects, there could be literally hundreds, including the sub-projects. For instance, Eclipse Foundation alone, which grew out of the IBM Eclipse project, has over 17 projects implementing protocols, device gateway frameworks, vertical frameworks, and tools. So we really wanted to focus on some of the more major initiatives while also maintaining and having a relatively diverse representation among open source IoT projects. Now, I will say that our research was intentionally skewed towards more software orientation than hardware, based on what we believe was the need coming from enterprise and startups in particular, to be able to connect to smart objects and devices, to be able to sense, control, communicate, store, and to analyze. Now, in terms of our research methodology for primary research, we employ a survey and an interview approach. Some of you may have been interviewed by me, and certainly when I speak at IoT World next week, I will see a lot of them as well. And for those open source projects willing to participate in our study, A survey with granular questions were distributed in advance, and then followed up with a video interview to obtain context and clarification on their capabilities and applications. And for secondary research, we looked at websites, research reports, and secondary sources to be able to obtain information for comparison and benchmarking purposes. Now, for those projects that did not participate in our survey or interviews, I will say that they may be somewhat at a disadvantage because there may be some granular information that they hold as a contributor that perhaps maybe was not easily accessible on public sites or documents. Now, furthermore, as a disclaimer, we did not download, install, or evaluate the source code on GitHub or other repositories. Now, the reason I'm explaining that is because it's important that the capabilities that we documented are strictly based on survey results, interviews, and secondary sources. And for this reason, we're shy away from publishing anything like Gartner-like Magic Quadrant graphs or hard and fast best-in-class ranking to show competitive positioning of open source projects. So with those disclaimers out of the way, the list of IoT open source projects in the study classified by the category are the following. Note that some of the projects could fall under one or more categories. And given the time limitation for today, I'm not going to be able to cover all of them, and certainly I'd be lucky to cover even one per category. But I'll highlight what we think may be interesting to you. So we'll give you a few minutes to review the list quickly. Now what you're seeing here in this next slide is the survey questionnaire that was broken down into the following categories and details. Now this is only a partial list with just a few possible answers, but certainly there's much more than this here. And this gives us a broad sense in terms of how to evaluate and compare at the lowest level. And again, a detailed report will become available should you subscribe to the wait list for this report. Okay, so given, again, the time constraint, I'm not going to be able to cover all of these categories, just a few select, and I do want to spend a little bit of time on OpenHead, given the fact that we just reviewed people power. Now, to help us set the right context, this slide here is to help us to understand what are we talking about in terms of the more common IoT architecture. So starting from the bottom, the product or the IoT hardware and software. Then the next level is the connectivity layer that enables the communication between the IoT devices and the cloud. And at the cloud level, we have the smart product applications that manage the monitoring, control, optimization, and operation of product functions, and the business rules and the analytics engine layer. And you've seen some of the IFTTT things that PeoplePower does, for example. Application platform layer and the product database. On the left, we have PKIs, such as digital certificates for authentication and security system. On the right, we have external information coming from the outside of your firm, but also inside, including integration with your internal business systems and ERPs. The next slide gives you a granular view of the technology stack that we're talking about, separated by the application data layer, the transport layer, the network layer, the data link MAC layer, and the physical layer. Note that more common protocols and standards are intentionally listed on the right by layers, so you understand kind of the breadth. Again, this is not comprehensive by any means, but gives you a good picture. All right, so let's first review the industry standards and the consortiums. Again, as preface, it's not meant to be comprehensive, but to give you a cross-section of open source initiatives. So at the broadest level are the industry standards to address interoperability. And standards bodies and consortiums include the AllSeen Alliance, and I will disclose that I am a member of AllSeen Alliance, and their AllJoyn framework. The Open Interconnect Consortium, OIC, and their IoT open source software framework. The Industrial Internet Consortium, OASIS, IoT, M2M, Eclipse, and others are working on various aspects of standardization, creating open source software to provide reference implementations, specifications development, and certifications programs. Now, note that there are many overlaps between these consortiums, but from an enterprise or your startup perspective, you need to think about how to comply across these standards if you want to scale and have the breadth of interoperability. Now, the two largest bodies here that's defining the industry standards are the AllSeen Alliance and OIC. Now, both are hosted by the Linux Foundation. Now, the premise behind these standards is to enable a variety of devices built by different manufacturers running on different OS to connect with each other, to find and to communicate. Now, the standard plus the implementation of reference helps to ensure interoperability among products regardless of the manufacturer and across verticals, be it smart home, connected car, industrial automation, healthcare, and so forth. A little bit about AllSeen Alliance. It has 120 members, including Qualcomm, Microsoft, Panasonic, Sharp, Sony, LG. It's dedicated to enabling and driving the widespread adoption of products, systems, and services that supports Internet of Everything, with an open, universal development framework supported by a vibrant ecosystem and a thriving technical community. And it is the broadest cross-industry consortium to date that advances the adoption and innovation of the Internet of Everything in homes and industries. Now, AllJoyn, which is the gateway framework, works across OS, including Android, iOS, and Linux. And the gateway allows for remote access to devices and fine-grained management control of those devices. Now, in addition to allowing those devices to connect and talk to the gateway, it also allows through those gateways to the cloud and allows for devices and apps to talk directly with one another without the need for a gateway. OIC. OIC was founded in July 2014 and has 50 members, including Intel, Samsung, Cisco, Acer, Dell, and others. Between AllSeen Alliance and OIC, AllSeen Alliance again have been operating longer, so it is fairly more established. However, OIC is rapidly picking up industrial momentum. And there's another foundation that I want to just briefly mention, which is the Eclipse Foundation, which grew again out of the IBM Eclipse project. Has about 228 members, including IBM, Google, Oracle, BMW, Cisco, and Dell. This slide that you're seeing here are the more common and popular standards and protocols. AMQP, the Advanced Messaging Queuing Protocol, is an open standard application layer protocol for message-oriented architecture. Its key features are message orientation, queuing, routing, including point-to-point and publish and subscribe, and reliability and security. By the way, one of the open source projects called Chimera IoT in our study uses AMQP, Rapid MQ subscription, messaging public exchange to provide real-time mobile transmission of sensor data on a publish and subscribe model. CoAP, Constrained Application Protocol, is an application layer protocol that is intended for the use in resource-constrained internet devices, such as wireless sensor networks, low-power sensor nodes, switches, valves, components controlled or remotely monitored through the internet networks. Again, the key is that they're resource constrained. XMPP, Extensible Messaging Presence Protocol, is a communication protocol for message-oriented middleware based on XML. Now, originally called Jabber, it was used for real-time instant messaging, presence information, contact list maintenance. Now, it's been extended to use in publish, subscribe systems as well as IoT applications, such as for smart grid. So within our study, Siteware, for example, which is under the horizontal cloud platform, supports XMPP. MQTT, Message Queue Telemetry Transport. It's a lightweight publish, subscribe messaging protocol designed for resource-constrained IoT devices and low bandwidth, high latency, and unreliable networks. Again, MQTT is ideal for connections with remote locations where a small code footprint is required or the network bandwidth is at a premium. From Contiki to OpenHAB, open source Internet of Things, and others support MQTT. Now, from a sector and business use case, these standards and protocols are fundamental enablers to finding and communicating across profiles such as mobile, wearable, in-vehicle infotainments, TVs, cameras, printers, and appliances. We're going to eventually see a tight